Hello and welcome to the lecture. So, in this lecture, we will study about the color and the magnetic properties of coordination compounds. Now, first of all, let us study about the color of coordination complexes. Coordination complexes. Now, we know that one of the limitations of valence bond theory was that it was not able to explain why certain compounds they exhibit color. So that limitations, it was explained by CFT. Now, in the CFT case, we know that in the CFT case, there occurs the splitting of orbital, d orbital, it occurs. So that we have already studied. Suppose this is our d n case, so there will happen splitting. And the splitting, it will be like this. This will be our splitting. So the splitting, it will be like this. Now, because of this splitting here, there arises two types of sets. The first set, it was called as T2G set, and the energy above, or the high energy state, it was called as EGKs. Now, how the CFT it explained the color in case of coordination complexes, that we will study in this lecture. So suppose we have D1 case. Now, in the D1 case, what will we see? That the splitting will happen, the splitting will occur, and the splitting, it will be, this will be our T2G set, and this will be our E2G set. So this will be our T2G, and this will be our EG case. Now, we have here one electron. So according to crystal field splitting, what will happen here? This electron, it will make a transition from T2G to the E2G set. So a transition from here, let us write down this. A transition from T2G to EG set, it arises to the color of the coordination complexes. So because of transition from T2G set to the EG set, the color of the complexes, it arises. So similarly, suppose we had D3 case. So in the D3 case, what will happen? The splitting of d orbital will happen, and the splitting, it will be like this. So this will be our E2G, and this will be our EG. So here, this is our T2G like this. Now there will occur transition from, this is our EG. So there will occur the transition, it will be arises from T2G case to the EG case. So because of this transition, that is from T2G case to the EG case, there will occur transition. Now, how the wavelength of the color of these how the wavelength of the color of the complex, it varies. That will depend purely on the ligand field environment. So let us see how the ligand field environment, it will affect the transition in case of octahedral. So let us see ligand effect of color. Effect of color due to ligands. Now let us understand that thing. Suppose we have two complexes. We have iron and it is having water, and this is with the two positive charge. This is iron with the two positive charge, and this is having the water as a ligand. And we have here another iron complex with the cyanide, and this is also having 4 negative charge. This is having also 4 negative charge. So in the first case, the iron, it is present in its +2 oxidation state, and in the second case, iron, it is also present in its +2 oxidation state. Now in both these cases, what will happen? Crystal field splitting, it will occur. So the crystal, since this is D6 case, both of these are having D6 case. So this is our D6 case. Now in both of these complex, what will happen? Crystal field